Hello. In this video, we will be going over the law of sines. As a quick review, we know that the three trigonometric ratios of functions represent ratios of side lengths and right triangles. When we see the word sine, it's always sine of an angle. Angle A is that spot right there. Sine is the ratio of the opposite side from that angle to the hypotenuse. So in this case, we label opposite, that's one across from the A, hypotenuse always across from the B, or the right angle, and so 3 over 5. Cosine is the adjacent over the hypotenuse from A. There's the adjacent, which is 4. There's the hypotenuse, 4 over 5. It's in a ratio of 4 to 5. Tangent, opposite over adjacent, TOA, opposite of A is 5. And then adjacent is 4, 3 over 4, well, that's a 3, not a 5. We can also use these ratios to solve problems. We see that we're at angle 70 degrees, this is the opposite, we know that this is the hypotenuse, the function that uses O and H is sine. So as a review, we set up the sine of the angle 70 equals the opposite over the hypotenuse, that's going to be x over 14, and then we solve by multiplying by 14 on both sides. So we've essentially set up a proportion, kind of, put that all in the calculator, and we get x is around 13.2, we'll call that centimeters. So far, the ratios that we've been using have only been in right triangles, and so now the math gods, they got so bored that they're like, you know what, we're going to move on from right triangles, we're going to use non-right triangles, and they found another ruler theorem. So this ruler theorem, basically they found out, and it's important that we're going to label these correctly, okay? So once we actually get to labeling, probably label them correctly, but they found out by doing so many non-right triangles that in every triangle, there's another rule that each side, okay, so if anything on the side, it's proportional, so we can set a proportion, something about the side, something about sitting proportion, we've done this before. So the side is proportional to the sine of the angle across from it. So the sides aren't proportional like in similar triangles, now it's the side is similar to the sine of the angle across. So what the heck does that mean? Right, so how do we set up a proportion with this? Let's label things first. So we're going to label things, we're going to label the angles of the triangle with the uppercase. This is A, this is uppercase B, and then uppercase C. So uppercase means the angle, lowercase is going to be the side. And so if you look at angle A here, the side that's across from it, that is going to be side A. So that's across from the angle A. So across from angle B, the side across from it, lowercase is going to be the side. So this is going to be side B, lowercase b all the way across. Across from angle C is going to be lowercase c right here, like so. So always the angle and the side are across from each other. So how do we set up a proportion? We know that proportions are going to look like this. And so we know that the sides are the lowercase, so if side is going to be proportional, the side is, one of the sides are going to be here, so let's call this A. So if it's proportional to the sine of the angle across from it, what that means is that on bottom of this side A is going to be the sine of the angle, which is uppercase A. So we would set up our proportion like this. We would actually write whatever number for the A is here, 10 feet, and then we'd write sine of 30 degrees, whatever that angle is there, sine of 30 on bottom. That is the actual proportion. And so since there's a bunch here, we can set that up also. So this is going to be B, that's side B, proportional to sine of angle B. So we're going to put sine of uppercase angle. And since there's three, we can go ahead and write a third one. So when you set up the actual proportions, there's just going to be two of them, but we also can include C. So based on the information that's given to us, we're either going to choose A's and B's, so our proportion is going to look like that, and then we're going to solve it. Maybe it'll be A and C, depending on the problem, but once we have all the labels, we can actually use this to solve problems. Thank you, math gods. So let's solve this in our first problem. So here we have a triangle, and it says to find AC. So side AC right here is across from angle B, right? So if this is angle B, this is going to be lowercase b. So since we have to find AC, that side, we know we're going to use B and B, right? So we know we're going to use these B's because the angle is given and we have to find that side, right? So we know we're going to use that pair of B's. Okay, so we have the other information that's given to us for the sides is CB. And so if we label side CB, which is across from angle A, this side, CB, is actually just code word for lowercase a, because that's side A, side is the lowercase, and that's across from angle A. So we know we're going to be using A's also, right? So we're going to use A's as well. So let's set up our proportion. We are given our A. The A is the side, 14. And then the sine of the angle, we're literally going to write sine, because proportional to the sine of angle A. Angle A is 37 degrees. Is equal to, now we're going to do side B. Side B we don't know because we have to find side AC, which is side B. So we're going to put lowercase b here because we don't know that. We're going to put x sine angle B. So angle B is 34. So once we have our proportion, we just solve for the variable b. The b is dividing sine 34, so we're going to multiply by sine 34 to get that b by itself. Those cancel, bring down the b, put all of this in the calculator. Sine 34, close the parenthesis, multiply 14, divide sine of 37, close the parenthesis, and you will get 13 feet. Wow, thank you, math gods. That is great. Last example. We are given a triangle with 49 degrees, 23 degrees, and then we have one of the sides labeled. Let's go ahead and see what the problem wants us to find. It says to find CB. So CB is a line segment, so this is CB. So that means, let's find out what side this is. This is across from angle A, so we're going to label CB as lowercase a. So we know that we have to use A, so we're going to use the angle A as well. So we'll use those. Now let's figure out, are we going to use the B's or the C's? So we look at the information given to us. We see here that this 27 yards is across from this angle C. So if we use this angle C, we can also use the other C of 27. So those are the 4 pieces of info we're going to use. So you always need A and A and B and B, or A and C and C, or B and B and C and C. So it's always going to be a pair. Set this up. Our lowercase a, if we labeled it correctly, it should be no problem. Lowercase a is a. That's what we have to find. So you can put a or x. Sine of the angle a, because that's uppercase, 23 degrees. Equals, and then we're setting up c. Lowercase c is on top. That's the side. We are given that, so we labeled it lowercase, 27. And then over sine of angle C, because that's the uppercase C, which is 49 degrees. But we're trying to solve for this variable here, so we want to get that variable by itself by multiplying by sine 23 both sides, because that will cancel out. Bring down that A. When you put this all in the calculator, 27 divide sine of 49 degrees, close a parenthesis, then multiply all of that by sine of 23, then you will get 14 yards. Thank you for listening.